Let's try to understand characteristics of transformed functions. Now what I have done here is added few questions at the end of this series where we'll try to analyze the transformed functions and understand their characteristics. In each video, I'll tell you about one characteristics and leave the others for you to discover. So the idea is that when I talk about this particular case from the point of view of, in this case, increasing and decreasing interval, then this is what we'll discuss here. But for you, the question will be, write the other characteristics of the transformed function. Like, for example, domain and range, intercepts, any symmetry, all those characteristics which you had been doing so far. So that's the whole idea, right? So, and I think if you do like that, then you'll be well prepared for the test and you'll really enjoy this topic. So, a couple of videos which I've taken is, every video I've discussed one aspect and I've left the others for you, including the sketch for the function, right? So do it to the best of your knowledge and see how best you can do. Now this one is, the basic function is y equals to x squared. Let's go through it. Consider the function y equals to x squared. Write increasing decreasing interval for transformed function y equals to minus f of x minus 3. Now, you know y equals to x squared is like what? So let's kind of sketch it on the side so that we understand what are we talking about, right? So y equals to x squared is a parabola. There you go. Over the vertex at origin, and what we notice is that it decreases from minus infinity to 0, and after that it increases. So here we have a function which decreases from, let's say, minus infinity to 0, right, and increases from 0 to infinity, right? But when we transform it, then the increasing decreasing intervals will change. And the point to consider is the vertex. That is the point to consider. So where is the vertex here? So we'll say vertex is at 0, 0 for our function, which is y equals to x squared. So we'll basically try to see that when we do transformation, what happens to the vertex. And once we know that, then we can get an idea of decreasing and increasing intervals is split by the vertex. Okay, let's go back to our question. Write increasing decreasing interval for transformed function y equals to, let me rewrite now here, y equals to minus f of x minus 3. Now there is no need to substitute this there and get into complications. We know and understand transformation. Now what does this function indicate? This function indicates reflection on x-axis, right, and 3 units to the right. So basically it indicates that you need to reflect it on the x-axis. That means you need to reflect it like this and move it 3 units to the right. That means move it 3 units to the right. So that will be your transformed function. Do you see that? So basically it will come here from 3, and now you know intervals of increasing and decreasing, right? So that is how you can figure out intervals of decreasing and increasing. Now, we could do it even without graphing. For example, in the original function, what are the intervals? So we say in original function is x squared, right? And in x squared, so we have this decreasing interval, let me write decreasing, and increasing interval, right? So decreasing interval for x squared is from minus infinity to 0, and then increasing from 0 to plus infinity. Now, the idea is that 0, 0 is the vertex, correct? So we get two things here. One is the direction, second is the point. Now how will this point 0, 0 get transformed in our function, which is the transformed function minus f of x minus 3, right? That is the function. Now in this particular function, what happens to origin first thing we need to consider, because this point 0, 0 is referring to origin, right? Which is this vertex. So vertex actually changes in our transform function as y value get multiplied by minus. So that remains 0. And the x value you have to add 3. So vertex changes to 3 and 0. So that is transformed vertex, right? That is where it is transformed, correct? So this point changes and this point becomes 3 instead of 0. Do you see that? That changes to 3, right? Now, so that is a change in 3. Second is, when we do minus times anything, then direction changes. Do you understand? Why we are multiplying by negative things? So direction changes. So decreasing becomes increasing and increasing becomes decreasing. So because of this minus, these intervals swap. So this is the effect of minus. This is the effect of, I should point here this minus. Do you see that? This is first effect. And second is, because of this translation 3, right, these points get changed. Do you understand? These points. We do plus 3 here. And that is how we get our answer. And then we get our answer as that it increases from minus infinity to 3 and decreases from 3 to infinity. Do you see that? So it swaps. The point changes first thing from 0 to 3. So the vertex, which is at x equals to 0, here vertex is at x equals to 0, right? So where is the vertex? Vertex is at x equals to 0. That changes to x equals to 3. This is the location of vertex. So that 0 changes to 3. Do you see that? And because of this minus, they swap. And that's how we get our answer. I hope with the visual sketch here and kind of things which we have done on the left side, you get some idea of how the increasing and decreasing interval will get transformed or changed in such kind of functions. Right? Now, after doing all this, I want you to write down characteristics of the transform function, which includes domain range, intercepts, x and y intercepts, and any other property you can add. Thank you.